Last section of chapter 6, section 2. So this last part is talking about linear and angular speed. So if I have a circular disk, so here's my circular disk here. So there's my circular disk, and I have some point on my circular disk. So some point P on my circular disk. And there's two things we can talk about. We can talk about how fast that point travels around this circular disk. That is called linear speed. And then the next thing we can talk about is how fast this angle opens up. So how fast this angle right here opens up. So how fast that angle opens up around that disk. And that is called angular speed. So angular speed is how fast the angle opens up. Linear speed is how fast some point on the disk, how fast that travels around. Okay, so linear speed and angular speed, here are the formulas. So linear speed is just what you're kind of used to. It's just regular speed, distance over time. So we're going to use in this V for linear speed. And so linear speed represents V. And then for our distance, that's going to represent S, our arc length, right? Our distance around here, that's our arc length. That's why it's S. And then divided by T, our time. So that is linear speed. And then angular speed is a little bit different. If I can remember right, lowercase omega or something like that. I don't know, that's what it looks like. I'm unfamiliar with my Greek letters. Equals theta, so that's the angle, over time. So it's how far our angle travels over time, and that is I think it's omega or something like that. So those are the two different formulas. Now we can rewrite these and I can solve for arc length, I can solve for time on these, I can solve for my angle if I'm looking at angular speed. So you can manipulate these in many different ways. And remember, when we talk about these, our theta is our angle in radians. Okay, so our angle has to be in radians. All right, so this one can be really manipulated because we know arc length is just theta times our radius, right? So we can rewrite this one as theta times our radius over time. So that's linear speed. And then we can rework this because now I have theta over time, and I know theta over time is just my angular speed, right? So I can rewrite this a final time as linear speed equals angular speed times our radius. And so there I can have my three different types of linear speed. So depending on what I'm given in a problem, I can find the linear speed or the angular speed. And if I have the angular speed, then all I have to do is times it by my radius, and that will give me my linear speed. Okay. Okay, so here's an example. I am given this circular disc. I'm given a radius of 10 centimeters. I'm given an angular speed of radians per second. So, because theta is our angle that we're opening up to, and so we have this many radians per second it travels, and so we want to find theta when t equals 6. Okay, so right now we're given a radius, so we're given a radius, and we're given our angular speed, right? So what can I find from that? Well, I know that my linear speed, as we just talked about, is our radius times our angular speed. So I can times those together and I get our linear speed, which is the final question here. So I can easily solve for that. So when I'm working this, I can just go ahead and multiply those two. So I have 10 times pi over 18. Can reduce these fractions here by 2, so that's 5, and that's 9. So our linear speed is just 5 pi over 9. So that was pretty easy. And then we could use that to go backwards and find, okay, we can find theta when time equals 6, or distance. We can use this same formula. We know this, that our angular speed is theta over time. And so, and we know our angular speed is pi over 18. So that it would equal theta over time. Now I can go ahead and enter in a time of 6. So now I can enter in a time of 6. multiply both sides by 6. This would just cancel out to a 3. That would cancel out, so theta equals pi thirds. So our theta is equal to pi thirds. So there's our theta, is pi thirds. And now I can go ahead and find our distance. Our distance a little bit more, because distance mostly has to do with linear speed, s over t, right? So an s I can rewrite as theta times r, because I know my theta. Well, I know my theta now. I know my theta now, and I know my r over time. And again, my time is given as 6 seconds. So here we can go ahead and enter that in. So velocity equals angular speed equals, linear speed equals our theta, which we know is pi thirds, at 6 seconds. And we know our r is 10. And we know it's 6 seconds. And well, we don't really have to go into this really, because really we know that these can just cancel out, and really we just get our s equals q times r. And we already know what our q is, q times r, theta times r, our angle. And that will give us our arc length, which that's what it asked for, right? D. So I didn't even need to go into this complicated thing. Sorry about that. So that's just 10 pi thirds. So there's our arc length, or our distance, 10 pi thirds, and we already found out our linear speed. So we're all done. So really these problems are just a manipulation of those two formulas, either our angular speed or our linear speed. All right, so here's one more example. Finding kind of the same thing, angular speed and linear speed. I guess here you really need to make sure you're in this correct units that they want you to be, centimeters. So like this is how many revolutions per minute, and it might want in per second here, in per second, so we're gonna have to do some conversions. But anyways, so we can go ahead and take, first we can convert this to radians per second, and here we have revolutions per minute. So we want radians per minute, and then we can convert those per minutes to per second. Okay, so we can take this 80, multiply it, because every revolution is 360 degrees, which is 2 pi. So if we multiply this by 2 pi, I would get 160 pi radians per minute. And now I want radians per second, so I just have to divide that by 60. So divide that by 60, divide that by 60, and we get, after reducing, cancel out those zeros, right? 16 and 6 cancels out to 8 and 3. So 8 pi thirds radians per second. So that's how many radians per second we're going. Okay, now we can go ahead and find our angular speed and our linear speed, because now we're in per seconds and we're in radians per second. So we know our angular speed right here is right here, 8 thirds pi radians per second. Because our angular speed is how fast the angle travels around, right? And make one whole revolution is 2 pi. So that's kind of all the work we did there. So we have that answer. Now I want linear speed. Well, to convert to linear speed, all we have to do is just switch and manipulate this formula right here. Because we already know that this is v is equal to our angular speed times our radius, and we already know our angular speed, which is 8 pi thirds. And we can times that by our radius 6, cancel these 3 and 6, and so we get 16 pi. So we get 16 pi, so v is equal to 16 pi. That would be centimeters, because that's what our radius is in centimeters per second. since we converted those to per second, or which is approximately 50 centimeters per second. So there you go. So that's how you do it.